Hello guys, so I would like us to look at the solution to this question right here. Given u is equal to tan inverse y over x, show that del 2u del x2 plus del 2u del y2 is equal to 0. So solution, u is equal to tan inverse y over x. So I can be able to write this tan onto this other side so that I have tan u is equal to y over x. Now, differentiating this with respect to y, I'll have sec squared u del y is equal to 1 over x. Okay, then if I make del u del y the subject, I have 1 over x sec squared u. I in turn need to write this with respect to x and y. So I look at the relationship between tan and sec. 1 plus tan squared theta is equal to sec squared theta from trigonometric identities. So I can be able to replace x squared u with, so I can be able to write this as 1 over x. Instead of sec squared u, I can have 1 plus tan squared u. I already know the value of tan u is y over x. So tan squared u can be replaced with, so I'll have dy del u del y is equal to 1 over x into 1 plus, instead of tan squared u, I'll have y squared over x squared. Okay. So that in turn gives me 1 over, I have x here. If I put this under the same LCM, that is x squared, this will be x squared plus y squared. So this simplifies to this x, and in turn I have x over x squared plus y squared. Then now I differentiate this again with respect to y so that I get the second derivative using quotient rule. So let this be u and let this be v. So del 2u del y squared will be equal to u prime v minus v prime u. All this divided by v squared. So u prime with respect to y, that will give 0, multiplied with v, which is x squared plus y squared, minus v prime, differentiating this with respect to y, that will give 2y, multiplied by v, that will give x. All this divided by x squared plus y squared squared. And this will give minus 2xy over x squared plus y squared squared. We do the same for the second derivative with respect to y. So u is equal to tan inverse y over x. Bring this to the other side, we have tan u is equal to y over x, and we can be able to simply just write this as tan u is equal to y x raised to power minus 1. So differentiating with respect to x, we'll get sec squared u del x is equal to, differentiating this with respect to x, we'll have minus y x raised to the power minus 2. So making del u del x the subject of the formula, del u del x is equal to minus y, can be able to write the x squared down here, sec squared u. And this in turn gives minus y over x squared, 1 plus tan squared u, which simply gives minus y over x squared into 1 plus tan squared u is the same as y squared over x squared. So this gives minus y over x squared plus y squared. This is our del u del x. Differentiate again with respect to x to get the second derivative. So del 2u del x squared will be equal to u prime. Differentiating this with respect to x will get 0, multiplied with v minus v prime with respect to x, we will get 2x multiplied with u minus y, all this divided by x squared plus y squared squared. So this simply gives minus minus will be positive 2xy over x squared plus y squared squared. So the question was to show that if we get the second derivative, the second derivative with respect to y and with respect to x, add them to show that they give a 0. And clearly, as you can see, if you add those two, you get a 0.